We will start the chemical bonding. In this chapter, you are going to learn about recognize the stability of noble gas configuration and about the octet rule, formation of ionic bonds, properties of ionic compounds, formation of covalent compounds, describe the formation of single, double, triple bonds with the help of Lewis dot method, and lastly, you are going to study about the properties of covalent compounds. So let us study firstly about what do you mean by chemical bonds. So we can define the chemical bonds as the atoms are held together in compounds by the forces of attraction. Chemically, we can say that in nature, whatever exists is made up of atoms. So these atoms are highly unstable. So to be stable in the nature, they need to obtain a particular configuration. And this particular configuration is nothing but called as octet configuration, which we are going to study later. So what do you mean by this octet configuration? In short, we can say that the atoms should have 8 electrons or at least 2 electrons in their outermost shell. Then they are to be stable is called as a octet configuration. So to be stable, these atoms will go and combine with the another atom, or these atoms will get attracted to the another atom. So this attraction which hold them together is called as a chemical bond. We can also define chemical bond in another way, that is, it is the attraction which bind 2 or more atoms to form molecule or a compound. Means in the nature there may be a molecule or there may be a compound. When 2 similar atoms combine each other, it results in a formation of a molecule. When 2 different atoms combine together, it results in a formation of a compound. So to form either molecule or a compound, the atoms will undergo bonding by the form of a chemical bonds. So let us explain this with the help of an example. So we have an example, that is, in the diagram you can see here, that is hydrogen chloride, HCl. So you can see here the hydrogen which is having a single electron in its outermost shell, but it is highly unstable because it do not have 2 electrons. So it will go and combine with the chlorine to get 1 electron, because chlorine is having 7 electrons in its outermost shell. So when you count here, we have 7x, right? So chlorine is in requirement of 1 electron, and hydrogen is also in requirement of 1 electron to attain the stable configuration, that is octet electronic configuration. So hydrogen will go and combine with the chlorine, resulting in a formation of a chemical bond. So this is how in nature almost all the compounds or the molecules will undergo bonding to be stable. So what is the basic purpose of chemical bonding is to remain stable. So let us move for the next slide, that is, we have types of bonding. There are 2 important types of bonding. One is a ionic bond and another is a covalent bond. Let us first study about the ionic bond. The chemical bond formed by the transfer of electron from a metal to a non-metal is known as a ionic or a electrovalent bond. It means that whenever an atom will combine with the another atom by the complete transfer of its outermost electron, it should transfer completely one of its electron to the another atom, such a bond is called as a ionic bond. So here, whenever there is a complete transfer of electron from an atom, the one atom becomes metal and another atom becomes non-metal. That is, an atom which donates an electron or which gives an electron completely is called as a metal, and the atom which accepts the electron or which gains the electron becomes a non-metal. So the interaction between or the bonding between a metal and a non-metal is known as a ionic bond, or it is also called as a electrovalent bond. In another way, we have another definition for electro that is ionic bond. That is, it is an electrostatic force of attraction which holds the cation and anion together is known as a electrovalent bond or a ionic bond. That is, whenever the two atoms are held together, they are held together by a force called as an electrostatic force. Since they are transferring the electrons completely, so there is a presence of a force between them that is called as a electrostatic force. So this kind of electrostatic force of attraction between a cation and an anion is known as a ionic bond. It means that an atom which donates electron is called as a cation, and an atom which accepts the electron is called as a anion. So there are presence of charges. So charges are nothing but it is a electrostatic force of attraction. So such kind of bond is called as a electrovalent bond or a ionic bond. Now we will study this in detail by taking an example, that is sodium chloride. That is, when Na, that is sodium atom, combines with Cl, that is chlorine, it results in a formation of a common salt, that is sodium chloride. So you can see the diagram here. The atomic number of sodium is 11, right? So whenever we write the electronic configuration, we have outermost shell 1 electron. They have shown there. The outermost shell has 1 electron. So sodium is highly unstable, right? Because it don't have octet configuration. Neither it has 2 electrons nor it has 8 electrons. It is highly unstable. So it will be in a search of another atom. So it will go and combine with the chlorine. When we come to chlorine, chlorine has an atomic number 17. So when we write the electronic configuration, the chlorine will have 7 electrons in its outermost shell. So it is in requirement of 1 electron to become a octet electronic configuration. So this sodium will completely transfer its electron to the chlorine. When it transfers completely one of its electron to the chlorine, sodium becomes positive ion. It means that it becomes a cation. And chlorine, when it accepts the electron, it becomes an anion, or it becomes a non-metal. So the bonding will be created between them, that is cation and the anion. Such kind of bond is called as a ionic bond, and the compound is called as a sodium chloride. Now this sodium chloride is stable in nature. In this way, most of the atoms will undergo bonding by the complete transfer of its electrons to the another atom to obtain an octet electronic configuration. Such kind of bonds is called as a ionic bonds. Now we will move on to the next slide, that is properties of ionic compounds. Till now we studied how the ionic bond is being formed. We will study some of the important properties of the ionic compounds. The first important property is a physical state. So what is the physical state of ionic compounds? They are crystalline solids and brittle in nature, right? So what do you mean by crystalline solids? They are highly solid in nature. They are neither liquids nor they are solids. Basically, they are not the gaseous. They are solid in nature and they are highly crystalline. So you can see the picture, crystalline in the sense, the best example I can give you for crystalline is a rock salt. They are highly crystalline in nature and they are brittle. Brittle in the sense, when you try to break them, okay, they do not change their shape. When you apply a pressure, they do not change their shape. They get broken, just like a rock salt. So they are highly brittle in nature. So this crystalline and brittle nature of the ionic compounds is because of the regular arrangement of the atoms within the compounds. Due to the regular arrangement of the sodium and the chloride, when we take an example of rock salt, they have solid in nature and brittle in nature. So we can say physically the ionic compounds are crystalline solids and brittle in nature. The next important property of the ionic compounds, that is melting and boiling points. So when we see the melting and boiling points, we can say that the ionic compounds have a very high melting and boiling points. They have a very high melting and boiling points. Why? Because what is the basic reason for the high melting and boiling points in the ionic compounds is because of the presence of strong electrostatic force of attraction between the ionic compounds. It means that we require a very high energy to separate these two atoms when they are bonded together by the electrostatic force of attraction. So the ionic compounds have a very high melting points and the boiling points. So some of the examples for this we can see, that is the melting point of a sodium chloride. As I told you, sodium chloride, that is NaCl, which is also called as a common salt, is 1074 Kelvin, or it is 801 degrees Celsius. Means we require 801 degrees Celsius to change the state of a sodium chloride. When we want to boil it, that is boiling point, it is 1686 Kelvin, that is about all around 1430 degrees Celsius. We require so much high energy to change the state of the ionic compounds. We'll move for the next important property of the ionic compounds, that is electrical conductivity. So how about the electrical conductivity in case of the ionic compounds? So they conduct the electricity in aqueous solution. Yes, we can say that ionic compounds are good conductors of electricity. They are good conductors. Why? Because of the, in simple words we can say, because of the presence of ions. So let us see this by an activity. So this activity is called as electrolysis process, right? It is called as electrolysis. So we have an electrolytic tank, right? It is being filled with the electrolyte, that is a sodium chloride. It is filled with the liquid, that is a sodium chloride. And when we apply the heat from the bottom and immerse the two electrodes, those two electrodes, one is an anode and another is a cathode. Cathode is negatively charged, anode is a positively charged. And when we connect them to the circuit, we complete the circuit by inserting a bulb, right? By inserting a bulb. So when we heat it, right? When we heat it, what happens? The bulb will glow. Ultimate result is that bulb will glow. How that bulb will glow? It is because when we apply the heat, the electrolyte, that is molten sodium chloride, will undergo dissociation, means it will break up or it will lyse into the sodium plus ions and chlorine minus ions. The sodium plus ion will move towards the cathode. You can see in the picture there. It will move towards the cathode, that is negative electrode, and the chlorine minus ion will move towards the anode, that is a positive pole. As a result, there is a flow of charges from one electrode to the another electrode, and this flow of charges is nothing but the electricity, and since the electricity is flowing, the bulb will glow. So what we can infer from this experiment? We can infer that the ionic compounds are good conductors of electricity. That is, we have taken sodium chloride, which is also an ionic compound. We can say that the ionic compounds are good conductors of electricity. We'll move for the next important property of the ionic compounds, solubility. Right? So how they are soluble, where they are actually soluble? They are soluble in water. Basically, they are soluble in water. Why? Because water has high affinity towards the ionic compounds. So when the water will combine with the ionic compounds, they solubilize the ionic compounds very easily. So we can say that the ionic compounds are soluble in water, but we have some exceptions like silver chloride, barium sulfate, and calcium fluoride. Though these are ionic compounds, but they have less affinity towards the water molecule, so they are soluble but not easily. So we can take these three ionic compounds are exception for the solubility. So till now we have seen about the ionic bond and the properties of the ionic compounds. Now we'll move upon to the next important topic, that is covalent bond, right? So what do you mean by covalent bond? The covalent bond forms when the force of attraction and the repulsion balance each other and the potential energy is minimum. Yes. So covalent bond is nothing but it is a bond which is formed between the two atoms. Again, here also atoms want to be stable in nature. They undergo bonding, but the way of bonding is different. As in ionic bond, they bonded by the complete transfer of electrons. But here in covalent bond, they will bind only when the forces of attraction and repulsion will balance each other. In other words, we can say when they reach the equilibrium. Right, when the two atoms will reach the equilibrium in position, they will bind each other, or we can say that when their potential energy is minimum. When the two atoms potential energy is minimum, they undergo bonding, and such kind of bonding is called as a covalent bond. We have another definition. In short, we can say, what do you mean by covalent bond? It is a bond which is formed by the sharing of electrons. As in case of ionic bonds, there was a complete transfer of electrons. Whenever there is a complete transfer of electrons, only there is a formation of ionic bond, whereas in covalent bond, there is an equal sharing of electrons between the atoms. Then only there is a formation of a covalent bond. You can see the picture here, right? So there are two atoms, hydrogen, hydrogen. So each hydrogen is donating one electron. So they are sharing. There is no complete transfer of electron from any one of the atom. They are sharing each other. So such kind of bond is called as a covalent bond. We will see the types of covalent bond. We have three types of covalent bond, like single covalent bond, double covalent bond, and the triple covalent bond. We will see first one, that is a single covalent bond. So definition is very simple. If a single pair of electrons are shared, it is a single covalent bond, right? So if only one pair of electrons has been shared between the two atoms, then there is a formation of a bond between them. Such kind of bond is called as a single covalent bond. You can see here the example of a chlorine. I have taken an example of a chlorine molecule. So when we see the chlorine atom, right, it is having the atomic number 17. As I told you already, it is having atomic number 17. When we write its electronic configuration, the outermost shell will have 7 electrons. Right? When we count these dots, that is, we have 7 electrons. So this atom is highly unstable. So it wants some other atom to combine to become stable in nature. So there is another chlorine atom which is also having 7 electrons in its outermost shell. So these two chlorine atoms will combine, right? So each chlorine atom shares 1 electron each. Like one atom shares 1 electron, another atom shares the another electron. As a result, the chlorine molecule, that is Cl2. Whenever we say chlorine molecule, it is Cl2. When we say chlorine atom, it is only Cl. So the chlorine molecule will have the stable electronic configuration, that is 8 in their outermost shell. Now they are stable in the nature by the formation of a single covalent bond. Since here the pair of electrons shared is only one pair, so the bond formed is called as a single covalent bond. So this is how the single covalent bond takes place, formation takes place by the sharing of a single pair of electrons. We'll move for the next type of covalent bond, that is double covalent bond. So here, if two pairs of electrons are shared, it is a double covalent bond. So we have an example. Yes, oxygen molecule, right? So oxygen, what is the atomic number of oxygen? It is 8. Atomic number is 8. So when we write the electronic configuration for the atom, that is oxygen, we have 6 electrons in its outermost shell, right? We have 6 electrons. The first shell will have 2 electrons. The last shell will have 6 electrons. So again, this oxygen atom is highly unstable. So to reach octet structure, the oxygen is in search of 2 more electrons. It is in need of 2 more electrons. So this oxygen will go and combine with another oxygen atom, which is also in requirement of 2 electrons. So each of the oxygen will share 2 electrons each. That is, the sharing of 2 pairs of electrons takes place from each of the oxygen atom. As a result, there is a formation of an oxygen molecule, that is O2 molecule, which results in the formation of a octet electronic configuration. When they bind each other, that is O and O will bind each other, the result in the formation of an oxygen molecule by the formation of a double covalent bond. Why? Because there is a sharing of 2 pairs of electrons. Since there is a sharing of 2 pairs of electrons, it results in a formation of a double covalent bond. We'll move for the next important type of bond, that is triple covalent bond. If 3 pairs of electrons are shared, it is a triple covalent bond. Very simple. If 3 pairs of electrons are shared, it is a triple covalent bond. Let us study this with the help of an example, that is nitrogen, right? So again, here atomic number of nitrogen is 7. So when we write the electronic configuration of nitrogen, we will have 5 electrons in its outermost shell. The first shell will have 2 electrons. The remaining 5 electrons will be in the last shell, right? So again, to reach the octet, the nitrogen is in a search of 3 more electrons to reach its octet electronic configuration. Without that, it is highly unstable, right? So this nitrogen atom will go and combine with the another nitrogen atom. So each of the nitrogen atom shares 3 electrons each. So we have you can see the electrons which are shown in red color, they are shared electrons, right? So each of them are donating how many? That is 3 electrons. So they are sharing 3 electrons. So 3 pairs of electrons are being shared. As a result, there is a formation of 3 bonds. So this is how the nitrogen, which was highly unstable in the nature, it will be stabilized molecule. It will exist as a stabilized molecule, as a nitrogen molecule, by the formation of a triple covalent bond. So on the whole, what we can say is that in the nature, the atoms will exist as a stabilized form by the formation of bonds. Either it may be by the complete donation of electrons, that is a formation of a ionic bond, else by the sharing of the electrons each other, that is by the formation of a covalent bond to reach the stabilized electronic configuration, that is octet electronic configuration. We'll move for the next important slide. That is, we have some properties of a covalent substances. As we have studied properties of ionic substances, we have some properties of covalent substances. The first important property, physical state. So as I told you, in case of unlike ionic compounds, they exist only as solids, but the covalent substances, they exist as a solid, liquid, as well as gaseous, because there is a less force of attraction between the covalent compounds as compared to the ionic compounds. So the covalent substances will exist as a solid, liquid, or a gaseous in state. Coming to the next important property of the covalent substances, that is melting point and the boiling points. So here what we can say is, comparable to the ionic substances, the covalent substances has a low melting point and the boiling points. The reason is again the same, because there is a less force of attraction between the covalent substances and it is very easy to separate them. We require a very less energy to separate the covalent atoms. So we can say that the melting points and the boiling points is low for the covalent substances. We have an example. The melting point of a naphthalene, which is a covalent compound, is 353 Kelvin, that is 80 degrees Celsius. Similarly, the boiling point of carbon tetrachloride, that is CCl4, is another covalent liquid compound, is 350 Kelvin, that is 77 degree Celsius. So it is quite less when compared to the ionic compounds. The next important property of the covalent substances, that is electrical conductivity. So the covalent substances are poor conductors of electricity. Means they are not good conductors of electricity, they are the poor conductors of electricity. So again we can carry out the same activity, that is the electrolysis process. So this is just to understand as we have understood the ionic compounds. So here, to transfer the electricity or for the flow of electricity, there should be a requirement of ions. So you can see the ion migration they have shown. There should be a migration, that is positive ions to the negative pole and the negative ions to the positive pole, so that the bulb will glow. But when compared to the covalent compounds, there are no presence of any ionic charges. So we can say that the covalent substances cannot conduct the electricity as like ionic compounds. So the covalent substances are poor conductors of electricity. The next important property of the covalent substances is solubility. So covalent substances are insoluble in water, but they are soluble in organic solvents, right? Like organic solvents, for example, ether, or you can say ethyl alcohol. These are some of the examples for organic solvents, right? So they are insoluble in water because the water has less affinity towards the covalent compounds. The water is also one of the ionic substances. It has a polar covalent bonds. Water is having a polar covalent bonds, so it has less affinity towards the covalent substances. So the covalent compounds are not soluble in water, but they are soluble in organic solvents. So up to here, we have studied about some of the important properties of the covalent substances as well as about the ionic substances. We'll move on to the next important topic, that is octet rule, right? So this is one of the most important topic we can say, that is the octet rule. What does it defines? Atoms tend to attain a configuration in which they have at least 2 or 8 electrons in their outermost shell, right? The atoms tend to attain, means they want to be stable in this nature. So they tend to attain a configuration. So what is that configuration? They should have at least 2 electrons. That is, least in the sense they should have at least 2, else maximum in the sense they should have 8 electrons. Then only they are stable in the nature. So to attain this electronic configuration only, the atoms will undergo bonding. So this configuration is called as octet configuration. It is called as what? Octet configuration. This octet rule was being given by the scientist Lewis. So he has told that this rule was being followed by almost all the atoms to obtain a stability in the nature. So this is called as a octet rule. Next important topic, that is noble gases. So what are these noble gases? So when we define it, so you have an examples of a noble gases, right, in the table. So when we define it, noble gases did not react with the other elements, means they do not react with any of the elements in the nature to form the compounds. In other words, we can say they were non-reactive. They are highly non-reactive. They don't react with anyone in the nature. Why? Because they are highly stabilized. They are highly stabilized since they have a octet electronic configuration. They have a octet electronic configuration. So let us see this with an example we have in the table. When you see in the table, that is, we have helium, neon, argon, krypton, xenon, and one more is a radon. We have almost 6 noble gases in the nature. So when we take an example of a helium, it is having the outermost shell 2 electrons. So it will satisfy the octet rule. So it is stable. As we have a definition, it should have at least 2 electrons, right? So it has 2 electrons, so it has satisfied the octet rule. When we take an example of a neon, the outermost shell has 8 electrons, so it has satisfied the octet rule. Argon also has 8 electrons in its outermost shell. Krypton also has 8 electrons. Lastly, xenon also has 8 electrons. Since all of these noble gases has octet electronic configuration, they do not react with anyone because they are already stable in the nature. So we can say that they are inert gases. The non-reactive gases are also called as inert gases. So in short, we can define noble gases are the gases, we can say, which do not react with other elements in nature, are called as noble gases. So till now you have studied about chemical bonding and some of the topics of the chemical bonding, right? Like what is the purpose of chemical bonding, what are the types of chemical bonding, that is ionic bonding and the covalent bonding, properties of chemical bond, that is ionic compounds and covalent compounds, octet rule, and some of the noble gases. We'll move on to the question and answer part. So first one, state octet rule. Just now we studied, right? State octet rule. Every atom has a tendency to attain 2 or 8 electrons in their outermost shell to get the stability like noble gases is called as a octet rule. Yes, they attain a tendency to attain stable configuration, that is either 2 or 8 electrons in the outermost shell is called as the octet rule. Second one, why noble gases are non-reactive, right? Just now we studied why they are non-reactive. So any answers? Yes, because they have inert gas configuration which makes it very stable. We can also say that because they have noble gas configuration. Both are right. They have inert gas configuration or they have noble gas configuration which makes it very stable. So they are non-reactive. Third one, in the table given below, 3 elements and their atomic numbers are given. Which of them are stable and will not form the compound, right? You should say which of the following A, B, C. That is, A has an atomic number 10, B has an atomic number that is 36, lastly C has 37. So for this, what you have to do, you should write the electronic configuration. So when you write the electronic configuration, to which element you will get 8 in their outermost shell, they are not reactive. So can I get any answers? Okay. So answer is A and B, right? So answer is A and B. That is, when we write the electronic configuration of A, we have 8 electrons in its outermost shell, and B also has 8 electrons, whereas C will have 9 electrons in its outermost shell, so it will be unstable. So we can say that A and B are stable. Name the 2 types of ions present in NaCl. Very simple. NaCl, that is sodium chloride. In other words, you can say it is a common salt. So what are the 2 ions? Any answers? Very simple question. 2 types of ions. Okay. What are the 2 types of ions? That is sodium ion, that is Na plus. Yeah, superb. Hemant, it is Na plus and Cl minus. Sodium ion, that is Na plus, and chlorine, that is Cl minus. Very simple. Na plus in the sense, why? Because plus it has donated an electron. Cl minus, why? Because it has accepted an electron, as we have already discussed. So we have 2 ions, sodium and chlorine. Next one, how many shells are present in a sodium ion, right? For this, you should know what is the atomic number of sodium. So atomic number of sodium is 11. So how many shells will be there? Any answers? Okay. Any answers, like when you write, yeah, Varsha, 4. How it is 4, Varsha? When you write an electronic configuration, see, I will tell you, you should write the electronic configuration with the help of a formula 2n square. 2n square, where n stands for shell number. Okay, if it is first shell, take n as 1. So I got from Hemant it is 3. No, it is actually the answer is only 2. See, we have 11. The electron, what is the atomic number? 2n square. Yes, 2n square. Take this n as the number of shell. Like if it is first shell, n is 1. If it is second shell, n is 2. Right? In that way you should take. So first shell, how many electrons will be there? 1 square is 1. So 2 ones are 2. Right? How many electrons will be there in first shell? 2. When we take for second shell, take it as 2. Very good. So 2 square. So what is 2 square? 2 twos are 4. 4 twos are 8. So second shell will have 8. Right? So on the whole we will have how many? That is 2 electrons. Since the sodium atomic number is 11, it will donate one of its electron. It will donate one of its electron. So we have 10. So on the whole, how many shells are filled? 2 shells are filled. So how many shells are present in sodium ion? Answer is 2. So please note down this formula 2n square. From that you can answer. So how many shells? 2 shells. Next question. Yes. What is the number of electrons present in Cl minus ion? See, here I told you already, whenever it is a minus, it is in a gain of electron. It is in a gain of electron, right? So what is the atomic number of chlorine? Very good. Hemant, 18, right answer. So chlorine atomic number is 17. So it is in a gain of 1 electron. So the total, it is 18. Next one. Name the type of force of attraction present in ionic compounds. Very simple. So what is the type of force of attraction present in ionic compounds? We have already discussed in the definition. So the type of attraction is, any answers? Yeah, right. Hemant, it is a electrostatic force of attraction. Exactly. Next question. In sodium chloride lattice in the sense it is a crystalline lattice structure which is a solid. How many Cl minus ions surround each sodium Na plus ions? So it is a literature, you should know it. No, they are asking how many Cl minus ions surround each Na plus. No, it is not one. I got from Hemant. So it is a literature, you should know the answer, like if you have studied somewhere. So answer is 6, right? So 6 chlorine ions will surround each of the sodium ions. Next question. Why HCl, NaCl are stable? So HCl is a hydrogen chloride, that is hydrochloric acid in other way. NaCl is a sodium chloride or common salt. Any answer? Very simple. Why they are stable? Okay. They have octet electronic configuration, right? See, because they have inert gas configuration, or we can also say they have octet electronic configuration, which makes it very stable. Next one. Due to chemical bond. No. Okay, 10th one. Why NaCl, that is sodium chloride, is a bad conductor of electricity in solid state? See, we have discussed that ionic compounds are good conductors of electricity. But here, they are asking why NaCl is a bad conductor of electricity in solid state, provided it is in solid state. So, any guess answers from anyone? Why it is bad conductor in solid state? Okay, see, whenever it is in liquid state, or whenever, in other words, we can say whenever it is in aqueous state, right, there is a separation of NaCl, right? Whenever there is a separation of NaCl, there is a flow of ions due to the absence of free Na plus and Cl minus ions. It is very important word, free Na plus. Since in solid, NaCl is not free to move, the ions are not free to move, so it is a bad conductor of electricity. We'll move to the next question. How covalent bonds are formed? Very simple. How covalent bonds are formed? Any answer? How they are formed? Okay. So they are formed, yeah, Hemant, mutual sharing of electrons. Yeah, how they are formed? Covalent bonds are basically formed by the sharing of electrons. A covalent bond is formed by the sharing of equal number of electrons between the two atoms. Is a covalent bond. 12th one. Show the formation of oxygen, HCl, Cl2 and N2. So we have studied these while studying the types of covalent bonds, right? There is oxygen molecule, chlorine molecule, nitrogen molecule and HCl. So you can see here, oxygen molecule, there is a sharing of 2 electrons each. So how this is called as a Lewis dot method. What it is called as Lewis dot method. So the Lewis has introduced this method to write the bonding of between the atoms. So here in first that is oxygen molecule, there is a sharing of 2 electrons, 2 pairs of electrons by formation of a double covalent bond. Coming to the next one, hydrogen chloride. There is a sharing of single pair of electron forming a single covalent bond. Coming to the third one, that is a chlorine molecule. There is a sharing of single pair of electron forming a single covalent bond. Lastly, nitrogen molecule. There is a sharing of 3 pairs of electrons forming the triple covalent bond. Next question. How many covalent bonds are present in the following compounds? You should say how many covalent bonds are present. We have studied single covalent bond, double covalent bond, triple. So how many covalent bonds are present in the following compounds? So options. Yes, first one, it is H2O. That is water molecule, HCl, hydrogen chloride, oxygen molecule and nitrogen molecule. So H2O, here 2 hydrogen combined with a single oxygen by forming a 2 covalent bond. So answer first one, it is 2. Yeah, I got from Hemant, it is first 2 option is 2 exactly. Then HCl, obviously it is 1 since the hydrogen combines with, yeah, and oxygen it is 2, right? It is a double covalent bond. Lastly, nitrogen molecule, it is a triple covalent bonds. We'll move for the next one. State loss or gain of electrons giving their number in the following changes, right? So there is a change of, that is nitrogen atom to the nitrogen 3 minus. So what does it mean? They are asking whether it is a loss of electron or whether it is a gain of electrons. If it is loss, how many number of electrons are lost? Yeah, you should say how many number, Hemant. You told gain, fine, but you should say how many electrons exactly. In first case, it is 3. Hemant, you are right. That is 3 electrons are being gained by the nitrogen atom. See, whenever they show minus, it is a gain of electrons, right? So 3 electrons are being gained in the first case. Second one, Cl. Yeah, 1, super. It is a Cl minus. Chlorine has gained 1 electron. Good going, Hemant. Third one, copper. It is 2 plus. So yes, loss of 2 electrons. Very good. Lastly, chromium. Chromium is again, that is a loss of 3 electrons. Yeah, exactly. Why ethyl alcohol is a bad conductor of electricity in its aqueous solution? So ethyl alcohol is a bad conductor of electricity in a aqueous solution. Any answers? Okay, I'll tell you the formula for ethyl alcohol, C2H5OH. Okay, answer, ethyl alcohol do not produce H plus ions in its aqueous solution, hence does not conduct electricity. Here, the hydrogen ions are not free to move. Yeah, due to the presence of alkyl group. Yeah, you can say that also. That is also fine by Hemant, due to the presence of alkyl group. In another way, we can say there are no free H plus ions. They are busy with the bonding with others like C2H5OH. So there is no conduction of electricity in case of ethyl alcohol. Hence, we can say it is a bad conductor of electricity. In short, there are no free H plus ions. That is the answer. Next question, 16th. Why ionic compounds conduct electricity in aqueous solution? Why only in aqueous solution? Why not they conduct electricity in solid state, right? So answer, any answers? Why do they conduct electricity in aqueous solution? Yeah, exactly. Presence of ion. Even in solid state, there are also presence, right? Presence of ion by Hemant. Yeah, because they can produce ions in aqueous solution. They can produce ions separately. Yes, very good. Hemant has told they are free to move. They can produce ions which are free to move in aqueous solution. So they conduct the electricity in aqueous solution. We'll move for the 17th question. Which of the following statements are correct for the ionic compounds? We have three statements, right? So, three statements here. First one, they are insoluble in water. Secondly, they are neutral in nature. Thirdly, they have high melting point. Yeah, it's right from Hemant, that is answer 3. They have high melting point because they are insoluble in water. No, they are soluble in water. They are neutral in nature. No, they are charged molecules. We cannot say they are neutral in nature. Lastly, they have high melting point. Yeah, from Varsha. Very good. It's option 3 is correct. Now, 18th. Classify the following compounds as ionic or covalent. We have some of the compounds given here, almost 6 compounds. So go through them. Just classify which of the following are ionic and covalent. So let us see first which of the following are ionic compounds. So first one, sodium chloride is ionic. Yeah, true. Hemant has given the answer. First one, sodium chloride is ionic. Next one, calcium chloride, whether it is ionic or covalent. Calcium chloride, that is CaCl2. Yeah, it is also ionic, right? Calcium chloride is also ionic. Third one, oxygen. Is it ionic or covalent? Any answers? Oxygen. We have discussed in a types of bond. Yeah, it is covalent. Exactly, Hemant. It is a covalent compound. Hydrogen chloride, HCl. Hydrogen chloride, yeah, it is an ionic compound from Hemant. Last, that is magnesium oxide, that is MgO. MgO. Fifth one is also ionic. Lastly, nitrogen. What about the nitrogen? Is it ionic or covalent? Yes, Hemant, exactly, it is a covalent compound. So out of this, we can say it is oxygen, nitrogen or covalent. The others are all ionic compounds. So 19th one, an element X has atomic number 11 and Y has atomic number 8. What type of bond they will form? Write the formula of the compound formed by reacting X and Y. So you have two elements. One element, it is 11 atomic number, another with the atomic number 8. So you should have a knowledge of atomic number here. So let me tell you, it is atomic number 11 is anybody? Atomic number 11, which element will have? Yes, exactly. It is a sodium oxide from Hemant. The compound formed is sodium oxide. The answer is sodium oxide. Yeah. We'll move for the last one. Name the type of bonds present in water molecule. So I told you, water is also a kind of a bond. It has also, it has a type of a bond. What type of bond it has? So any answers? Is it a covalent or ionic? No, we don't have hydrogen bond, Hemant. It is a covalent or ionic. So it is a, no, it has actually covalent bond. It is a polar covalent bond. It has a covalent bond. Water has a covalent bond. So we have discussed some of the most important questions from the chapter, that is chemical bonding. So there are few more questions. You can visit to the website, that is EDURapid.com. Just go through the questions. And if you have any questions, you can ask based on this topic. Any questions if you have. So I have a question here. What are the number of atoms? Yes, Hemant. Yeah. So I have a question here. What are the number of electrons present in Mg2 plus? So it is very simple. Mg2 plus. Can anyone tell me the answer? What are the number of electrons present in magnesium 2 plus ion? So you should have a knowledge for this. That is, atomic number of magnesium is 8, right? So when it has an atomic number, that is 12, and when you add 2 more electrons, it will be 14. 14 will be the number of electrons will be present in a, yeah, exactly. Any more questions from anyone? Okay, fine.